You're listening to the SPK and Associates podcast.
Hi, this is Chris McHale, co-founder and COO of SPK and Associates, which is a technology services company dedicated to accelerating product development in manufacturing companies. I'm here with Oleg Shilovitsky, who is a well-known blogger on product lifecycle management topics for the last 5 years. Oleg and I are presently producing a podcast once a month where we dive a little bit deeper into one of his key topics from recent blogging posts. So, Oleg, would you just take a moment to introduce yourself?
Yes, sure. Hi, this is Oleg Shilovitsky. I'm a blogger and consulting in PLM space, and I write my blog about PLM and related technologies, and you can read about this at beyondplm.com.
Okay, great. Oleg, today I thought we would focus on the broad topical area of the growing difficulty of managing BOMs in the product development lifecycle area. And this kind of divides up into two areas. One is the difficulty of managing BOMs across engineering disciplines, such as mechanical, EE, and software. And then also the growing difficulty of managing a BOM across the enterprise or across the product lifecycle. For example, from design into build, release, maintenance, service, and so on. Since this is a pretty broad area, I thought we would divide this up into two podcasts. And today we would focus on the difficulty of BOMs across engineering disciplines, and then follow up with another podcast shortly where we talk about the difficulty of managing the BOM across the enterprise. So you mentioned that you've been doing some blogging about this in the last month, or really over the last several months, and you've gotten a lot of interest, a lot of commentary on this topic, which is always a challenging topic. And I thought I would just start by asking you, in this area of managing a BOM across engineering disciplines, what are you seeing as the key challenges or holes today? If you could just start to set the stage for our audience by just describing what are the challenges and what are people faced with today.
Sure. Again, bill of material is such a fundamental topic, and as I mentioned, discussion about bill of material always can bring a lot of questions, commentary, and this is really a complicated topic. So if you think about anything that engineering and manufacturing is doing, you really cannot go and do anything without bill of materials. However, the biggest challenge and the biggest complexity in the bill of material recently in engineering came from the complexity of products itself. So if you think about products, they are not only mechanical or electronic or software. So today, every product that you create is sort of combination of all disciplines. So it's obviously some mechanical parts, assembly, and it's electronic and electrical parts. And today, even more relevant, we have software pieces, much more integrated in the product. So this is the root cause that we have a real complexity of product information and BOM in particular. And if you will start speaking to somebody in the organization and you start speaking about bill of material, so the immediate question that you will get, so what bill of material are you talking about? Is it electrical bill of material? Is it mechanical bill of material? So this kind of questions are coming first. And the second type of question that always coming together is how to manage them in a certain consistent way. Then you can represent the material of the product.
Okay, just a quick follow-up question on setting that stage. There's obviously these engineers, I would suggest anyway, typically are they are possibly sitting in different groups. You've got your mechanical engineers often in kind of one group, EE, and then software in another group. Obviously, they come together in terms of developing a product. but there tend to be different people, and they often are reporting to different people, and they even tend to have sort of different personalities, if you will. Just wondering if you have any comments on that and the softer area of just bringing different kinds of engineers together and the challenges that brings about before we dive into the tools and the technical ways that the bill of materials can be managed.
Yes, sure. That's a very good question because it certainly defines the level of responsibility and the organizational structure, organization in the company. And indeed, people are responsible for different pieces. So there are mechanical engineers responsible for how product will be built in terms of structure and its form factor significantly involved. And today, almost hard to bring any product without circuit boards. So electronics are heavily involved in, and software is coming. I think there we need to look on how these people are working together and what level of impact each group has in their development process. So clearly, mechanical parts are traditionally considered as something that will give a significant impact on everything else, because you can change form factor of the product, and the result of this, you will have to change electronic board, you will have to change fixture, you will have to change some components that probably will not fit the new form. So that's the more traditional way to think about ways to that mechanical parts will impact electronics. But obviously, there are some other examples. So what I think is important is to people to work together. And this is really difficult to do because they are using different tools.
So on this topic of different tools, when you and I were talking before, we had suggested, well, let me back up. The area that's typically referred to, or the tool that's typically referred to as PLM, or Product Lifecycle Management Solution, kind of grew out of the mechanical CAD area, right? So it initially was doing a lot of data management of the mechanical CAD files, and so it tends to be oriented more in that discipline, if you will. Although I think pretty much every PLM tool out there today will say, well, we manage other things. We manage the BOM and the data from other disciplines, and there would be differing views as to how successful that is, but that is, I think, what most are saying. So the thing I would like to hear your opinion on is there's this philosophy, especially growing now as the product is becoming more and more complex. There is this philosophy growing that each of the engineers in the engineering areas, who, as you mentioned, have their own tools, should really manage their own data with their own standalone data management tools that plug in and integrate beautifully with the design tools that they're using. So, for example, mechanical CAD, if they're using SolidWorks, use a product data management system that integrates beautifully with SolidWorks. If they're over on the software side, software developing in an IDE, use a software configuration management tool that marries into that beautifully. So again, the philosophy is let them do their own thing with their own tools and their own data management, and then at some points that are identified, then bring that data into a more centralized tool like PLM. Just wondering what your thoughts are about that, and that would be compared to the philosophy of no, everything should be in PLM, and PLM should have a breadth that's able to manage all of that. Just wondering if you have any thoughts or comments on that.
Sure. I think in order to answer this question, I think we need to go and understand a little bit industries that we are talking about, because it's not all the same across all industries. If you think about traditional for PLM industries like aerospace, defense, automotive, or even industrial equipment, the form factor was a significant influencer, and mechanical CAD systems were dominant in this industry. So this is what produced the vision of PLM, but it also was something that connected to MCAD in a very significant way. For this industry, traditionally the influence of electronics was much less significant. So, and also in terms of groups of development and people developed, the OEMs are very involved in the mechanical development much more than electronics, which in some cases was outsourced to suppliers, etc. So this is where the core philosophy of PLM came. Now, in parallel, the teams that, the companies that were in the electronic industry and the high-tech industry, they've been using electronic design tools for years, of course. And all these tools, they have their own data management solutions. They may call it PDM or not, but they do have separate data management solutions. So this is sort of reality that I think is in the industry today. So we will have mechanical CAD with their own PDM systems, and electronic and electrical CAD with their own PDM systems. And as much as products are getting more complex, companies are asking more questions about how to get them working together and not separately, because a lot of growing complexity are coming from the changes and how to manage the overall life cycle. And there is an impact between these groups, and to make them working together, it's a challenge for a company. That's why companies are coming with the questions how to manage it in a more efficient way.
So that's an interesting point, or those are interesting points, Oleg. And I'd actually like to dive in a little bit deeper on some of the differences between industries, because it strikes me that in certain industries, such as you mentioned, aerospace or automotive, there was the prominent, if you will, most important engineering area tended to be mechanical for a long time. But then as time has gone on in really every industry, but in these in particular too, the electronic and also the software components have grown quite drastically at times. And I've noticed myself it's an interesting thing to watch a organization grapple with a very different kind of engineering growing in prominence, and how to pull that data together and pull those teams together in order to have them produce something that is of high quality and to produce it efficiently as well. Since PLM tended to be this more of a mechanical CAD oriented a tool or solution initially, what do you see right now as pros or cons or capabilities of PLM in being able to manage the bill of materials, incorporating also the EE pieces or components as well as the software components? Do you think that this is being done well or not at all? Or what's your opinion about that?
Yeah, that's a great question. I think I would separate between two topics here. First of all, I would be speaking about mechanical parts and electronics. I think these are two disciplines that there is a huge demand for reconciliation and bringing this information together in PLM. I think the demand of customers is to more cohesive way to manage this information together. At the same time, if we come back to a question of software, I don't think there is some conclusion among customers how to do so, because software tools and software ALM tools, application lifecycle management tools, were developed significantly for the last 5-10 years, and they really mature and provide good solutions coming from also open source solutions and some proprietary solutions. So I don't think companies are ready to make a conclusion how to manage software in PLM systems. So I would expect here greater conversations in coming years, also between vendors and also among customers, to understand how to do it in the right way.
And really, there might be. I noticed your first comment related to mechanical and EE together, because what you're talking about there are still things, right, that have to fit together, that have to from a product perspective, well, that have to fit together and sort of work together. Whereas software has always been seen as, well, you're off there developing your code, and then, eventually a binary shows up, to be simple, and either gets, burned on if it's embedded or included as part of the product. And so it tends to operate a little bit off there by itself. And in some of the companies that I've seen, they actually will go so far as to really leave that with the ALM off to the side. And then when they get down to releases, or at least milestone releases or milestone builds, they'll just say, hey, give us a binary, and we'll put that in PLM, right, and have it be there. Is that the kind of thing that you've seen too, or have you seen more integration? I'm just curious, and I think our listeners might be curious as to hear what the different examples of that you've seen out there.
No, I think you defined it very well. I think you defined it good in terms of connection between mechanics and mechanical pieces and electronic pieces. These are really things that should fit together, and with software it's easier. I mean, the software baselines in terms of bill of material management are important, because you really want to know what software build you want to put in a particular product. So again, these tools eventually will have to integrate, but the level of integration, this information and bill of material will be defined, I would say, later with software, and earlier with electronics and mechanical parts.
Yeah. One thing that's interesting is that both PLM and ALM, this is maybe a little off topic, but both PLM and ALM over the years developed their own requirements management modules, for lack of a better term, within each of those tools or solutions. And they're slightly different, right, because the software requirements management tends to be a little bit more involved, and there's usually test cases and things like that need to marry up to those requirements. And there's less of that's written in terms of testing, on the mechanical side. What have you seen regarding the management of requirements in some of these various customers you've been involved with? Is it done really in PLM? Is it done completely separately? Is it done in ALM? Just curious what your experience of that has been.
Yeah, that's a great question, because requirements and management of requirements is one of the critical topics, if you will. Think how to close the loop between requirements and actually product that manufactured after all. So I think, again, there are multiple tools to manage requirements, and some of them more applicable for software space, for software development. There are tools that are open source tools. There are some proprietary tools, and there are tools that are used to manage requirements in PLM space. If you look on major PLM providers, they have requirement management tools, and some of them are done in partnership with other companies. Some of them are acquired. So this is certainly a topic on the table. I see it mostly implemented for larger manufacturing companies, where the higher level of complexity and many people involved, and greater complexity of communication and collaboration within teams. I think the smaller companies have tendency to use Excel spreadsheets to manage requirements, or some other traditional office tools. You can see it more often. They are not tell you that this is not important, but they just might have different priorities in terms of implementations of tools. Right.
I have seen in some industries, for example, life sciences, and I'm sure to some degree automotive, although I'm not as familiar with that, that the whole compliance question becomes pretty critical. And when it comes to requirements and testing and so on, there's a lot of traceability reporting that's required by the governing body that that particular industry is answering to. And so the whole requirements, test case, traceability question becomes quite time consuming. Especially if it's done on spreadsheets, it can be really time consuming. But becomes very time-consuming and a huge effort in and of itself. Have you seen much of that, or any comment on that?
I agree completely. I think the bill of material management, which describes all aspects of the product and also tracing back to requirements, is the most important and instrumental thing if you think about compliance and regulation. And as requirements to compliance and regulation is growing, the demand of companies for better bill of material management across disciplines is growing. It's not only in aerospace and defense, but it's also in consumer goods, and it's also in food industry, and it's a lot of in medical industry and equipment and pharmaceutical. So you can see a lot of regulated industries that requires better management of BOM and traceability between requirements and actually performing products.
It almost seems as if, and this is a little bit off the wall, but because product complexity is growing, and we'll talk next time, which we haven't even gotten into the whole aspect of managing the BOM through the enterprise or across the enterprise. It's almost as if the PLMs, ALMs, ERP, BOM modules or BOM capability within each of these tools, it's almost not up to the task in a way, because each of them are focused in their own areas of the company, so to speak, and in this case we could even talk about it across engineering disciplines. It almost seems as if there's a need for yet another tool, I hate to say, but something which can sit above these systems and really manage that BOM and be so much more flexible in terms of how it looks at the BOM and views the BOM and manages the BOM through the life cycle and across the engineering disciplines. So what do you think about that idea? That's
a great point and a very, very valid question. I've heard about this many times, and the question of do we need another system for enterprise to manage bill of material? I don't think there is a consensus, and there's no consensus between customers, and there is also no consensus between vendors here. I would guess for a customer, it goes directly to the organizational structure, because today multiple bill of material is often a reflection of the organizational structure or teams in the engineering department. And it should be some sort of agreement between teams how to manage that. And we know it's hard to get an agreement between people, because people like to own something that they do, and they don't like that somebody is touching what they're doing. So it's not just right. Between vendors, it will be a question of competition, because if ERP and PLM vendors are competing in the space for money of customers, so obviously they will pretend to manage more information, and bill of material is a perfect place where they can compete. You probably can see some attempts from PLM vendors to introduce more manufacturing-related bill of material functionality, and it obviously comes across some opinions of ERP vendors that the ERP is the best way to manage manufacturing BOM. So we will see this topics coming across as a competition between vendors.
Yeah, and as the in a way, as the product life cycle expands or grows or becomes more complex, and people are managing, the service side of things, when we start introducing the Internet of Things and trying to get smart devices out there that you're needing even more information about, or specific BOM information about. I just see this growing in complexity and becoming an ever-expanding problem.
Yes, I think the new complexity of products will introduce a greater complexity and requirements to the tools and the bill of material tools in the first place. So eventually, it will come down to the ability of a company to manage information in the right way. So if you need to release a product, then companies will have to come write bill of material information to get this product released and manufactured. And that's where it will come eventually to the solution.
Okay. Well, we could go on and on about BOMs and engineering disciplines, but I think we'll probably leave it at that point for today. And the next podcast, what I'd like to do is explore with you, Oleg, the management of the bill of materials across the enterprise or across the life cycle of the product and the challenges that are encountered there. So thanks so much for your time today. We really appreciate it, and for sharing your knowledge and your ideas with us. And we look forward to the next event.
Thank you for inviting me. I look forward to discuss this topic more. And thank you very much.
Okay, thanks, Oleg.
You're listening to the SPK and Associates podcast.